Okay, so I'm doing computer organization topic 2. So the first four questions are in the section of computer architecture. So the first question, the CPU or the central processing unit is a key component of a computer system which contains the circuitry that's necessary to interpret and execute the instructions of different programs used by the system. The ALU is the arithmetic logic unit, which is a part of the CPU that does all of the arithmetic, so mathematical and logical operations. The CU is the control unit, which controls the operations in the ALU and directs data flow. Registers. Registers are small and fast memories that keep intermediate values. Okay, the second question is to do with primary memory. So RAM, which stands for random access memory, and ROM stands for read-only memory, are both present in a computer system. RAM is volatile memory that temporarily stores the files that the person whoever's using the system is working on at that present moment, whereas ROM is non-volatile memory that permanently stores instructions within the computer system. Cache memory stores program instructions and data that are used repeatedly in the operation of programs or information that the CPU is most likely to need next. So the computer processor can basically access this information far more quickly from the cache than it can from the main memory, which speeds up the computer system's overall execution. The machine instruction cycle consists of the steps that a computer's processor executes whenever it receives machine language instructions. It's the most basic CPU operation, and modern CPUs are able to perform millions of machine cycles per second. This cycle consists of three steps: fetch, decode, and execute. So fetch is getting the instruction. Decode is understanding and breaking down the instruction so that the computer system knows what to do, and executing is obviously executing that specific instruction. Okay, the second questions are to do with secondary memory, section 2.5. So persistent storage is necessary in order to be able to keep all the user's files and data for later use. For instance, a hard drive is a perfect example of a persistent storage because it allows the user to permanently store various different types of data. Okay, operating systems and application systems 2.6 to 2.8. So the main functions of an operating system. Operating systems provide essential functions for managing devices connected to a computer. These functions include allocating memory, processing input and output requests, and managing storage devices. This device could be any kind of peripheral device, including a keyboard, a mouse, a printer, or any other devices that the user may have connected. Application software assists the user in managing their tasks, doing things like taking notes, conducting online research, setting alarms, keeping an account log, and even playing games. So all sort of like very common trivial tasks. Application software packages are intended to perform specific tasks. They facilitate different types of work, and they also enhance team communication. An example of this would be like the team systems that we use, or the whole sort of Microsoft environment. So common features of applications consist of things like toolbars, dialog boxes, menus, icons, etc. So it's basically the simplest GUI elements that users interact with on a regular basis whenever they're using the system. Things that make the UI easy to interpret and understand, and make the system essentially what makes the system very usable. Yeah. Okay, the next section is binary representation, so 2.9 to 2.10. A bit is the smallest unit of data in computing, which is represented by a 0 or a 1. A byte is a group of 8 bits. Binary basically computers use the digits 0 and 1 to store data because it only has two symbols. And binary can also sometimes be called base 2. Denary is a numbering system with 10 symbols, in which it's also referred to as base 10. And hexadecimal, this is a numbering system with 16 symbols. So this basically goes from 0 to 9, and then A to F. So digital devices represent numeric data using the binary number system, as mentioned above, the base 2 system with zeros and ones. So the binary system only has two digits, like I mentioned, 0 and 1. And so there's no other numbers within this system. So for example, the number 2 would be represented in binary as 1 0. Okay, and then this is the last section. This is on simple logic gates 2.11 to 2.13. So the AND gate is named because if 0 is false and 1 is true, the gate acts in the same way as the logical AND operator that we use in like pseudocode and Java and things like that. So the the image on the screen shows the circuit symbol and the logic combinations. So basically, the output is going to be true when both inputs are true. Otherwise, the output is false. So in other words, the output is only one when both inputs A and B are one. The OR gate gets its name from the fact that it behaves after the fashion of the logical inclusive OR. Um, the output is true if either or both of the inputs are true. If both inputs are false, then the output is false. So in other words, for the output to be one, at least one input out of A or B must be one. A logical inverter, which is sometimes called a NOT gate, to has only one input. So basically, it reverses the logic state. So if the input is 1, the output will be 0. And if the output is 0, then the input is, if the input is 0, then the output is going to be 1. So it just reverses whatever statement you put into the A value in this case. The NAND gate operates as an AND gate followed by a NOT gate. It acts in the manner of the logical operation AND followed by negation. So the output is going to be false if both inputs are true, otherwise the output is true. The NOR gate is a combination of the OR gate followed by an inverter. Its output is going to be true if both inputs are false, otherwise the output is going to be false. The exclusive OR gate acts in the same way as the logical either or. So the output is true if either but not both of the inputs are true, and the output is false if both inputs are false or if both inputs are true. Another way of looking at this is that if the output is one, that the output is one if the inputs are different, but the output is zero if the inputs are the same. And that is topic 2.